Everyone, this is Raktutpal Bora from Assam Downtown University. I welcome you to the video of Heat Transfer Lab. In this video, we'll discuss the experiment of heat transfer through composite walls. Aim. The aim of the experiment is to calculate the thermal conductivity of composite walls. So before going into the details, we have to know what is conduction. Since we are talking about composite walls, we have to know that the composite walls are made up of solid material. So when solid is in question, it should directly come to our mind that the heat transfer is happening via conduction. So conduction is the transfer of heat between substances that are in direct contact with each other. Okay, mainly which happens in the solid body, and the heat transfer happens because of the vibration of the molecules, which is also known as lattice vibration. The apparatus. In the left, you can see the apparatus where which is in an enclosure, rectangular enclosure, and inside that you can see a circular plates which is actually covered here by a cloth to minimize the heat loss. And inside that cloth there are 6 plates. In the center there is a heater, and in the top there are 3 plates, and in the bottom there are 3 plates made up of different materials. Top 3 plates and bottom 3 plates respectively are made of same material. Suppose heater, after that it is metal, then it is metal, then it is asbestos, then bottom also it's asbestos, then third plate it's wood, then bottom also it's wood. The whole setup is pressed via a press. You can see here a metallic plate is there, which is used to press all these plates together so that there should not be any gap between the plates, so that conduction occurs very properly. Now in the right you can see the control panel, which we'll be using to perform the experiments. The thermocouples are attached in the interface of 2 surfaces of the composite wall. Suppose from one wall to the other wall, in between the interface, thermocouples will be attached. There are a total number of 6 thermocouples, which are T1, T2, T3, T4, T5, T6. So 1 and 2 will be in the interface of first 2. 2 and 3 will be in the interface of second 2 in the top and the bottom, likewise. The specifications are such that the diameter of the plate, composite wall, each plate is 150 mm, and the thickness, that is the length of one plate or the slab, is 0.6 mm. Length is 6 mm. Theory. The Fourier law gives us the equation of conduction, which is Q is equal to minus Ka by dt into dt dx, where Q is the heat flow, K is the thermal conductivity, which we are going to measure, A is the cross-sectional area, which we can find out by the given specification, and dt by dx is the temperature gradient in the direction in which the heat is flowing. Procedure. At the beginning, we have to ensure the setup, all the mains is off, and the red color knob you can see here is also, which supply electricity to the control panel, is also off, and the thermostat is rotated to the extreme left. That means in the 0 position, the thermostat supply input to the heater. Okay, then we have to switch on the mains, and we will switch on the knob, the red knob, to supply electricity to the control panel. Then we will rotate the thermostat to give the heater input. In the top you can see the voltmeter indicator. In the bottom you can next to that, bottom of that, you can see the ammeter reading, ammeter indicator, current reading. We have to rotate the knob in such a way that we will take the voltage in the range of 40 to 100 volt. In between that, say you can take 40 volt, 50, 60, 70, likewise. After after putting the volt in the range between 40 to 100, we'll wait for 1.5 hours so that steady state condition is reached. Then we'll measure the temperature of the different thermocouples. This is the temperature indicator where the temperature of thermocouple 2 is showing. If we want to take the reading of thermocouple 3, you have to push the knob as it is shown here. Then you will get the reading of thermocouple T3. Again, if you push it, you will get reading of thermocouple T4, and likewise. Then all that readings you have to put in the observation table. We have to take readings after 10 minutes, and we have to keep on taking the readings 10 minutes after 10 minutes till the difference between two consecutive readings are almost negligible or the difference is 0. That means we can confirm that steady state condition is reached. That means with respect to time, the temperature readings are not changing. Then the value of Q, that is the rate of heat flow, can be given by the product of voltage and current. Then the area can be calculated from the specification A, and dt by dl, that is temperature difference, can be calculated from the observation table, and length from the specification. We put all this value in the Fourier's equation and we'll get the thermal conductivity of each and every material present in the composite wall, or we can get the overall thermal conductivity of the composite wall also. Thank you.